Hello friends, we will discuss about some troubleshooting related to the problems we find in the plasmid isolation. So sometimes we see that our DNA is resistant to cleavage with restriction enzyme. So if our DNA is resistant to cleavage with restriction enzyme, there can be several causes and there can be remedies also. So when DNA is resistant to cleavage with restriction enzyme, there are chances that insufficient care was taken to remove the fluid at step 3 or step 11. Step 11, which is basically in the midi preparation or maxi preparation, but in our previous video we have discussed only about mini preparation. So just remember, in the third step, if in some of these step, if insufficient care was taken to remove all the fluid, okay, so like in the first in the initial few steps, there are the like the steps where you have to remove all the fluid from the pellet. Okay, when you are pelleting it down, you have to remove all the fluid which contains the contamination which we do not require. That has to be done very carefully. Okay, so what remedy you can adopt? Extract the final DNA preparation with phenol chloroform. You can use phenol chloroform if you think that your DNA is resistant to cleavage. Okay, so the final DNA preparation we can extract with phenol chloroform, uh, recover by standard ethanol precipitation, which is the same which we already have discussed in the protocol in the previous video, and subsequent washing with 70% ethanol. Okay, so when you find that your DNA is not able to be cleaved with restriction enzyme, you have to extract the final DNA preparation with phenol chloroform. Okay, then followed by ethanol precipitation. Okay, then washing with ethanol. Okay, there is another way out, that carry out the restriction digestion in a larger volume using five-fold more enzyme. So if you have enough resources, you can perform the second method, and at the end of the digestion, recover the DNA by standard ethanol precipitation. Okay, so this is the method when we use when our DNA is not cleaved with restriction enzyme. Okay, now there can be another cause also, that some strains of E. coli like HB101 and their derivatives, they shed their cell wall components that persist through purification of the plasmid DNA. So even after purification, cell wall remain persist in case of some E. coli strains, and these cell wall components, they inhibit the action of restriction enzyme. In that case, what you will do, you will resuspend the bacterial pellet in ice cold STE, okay, and recentrifuge. Okay, and you have to discard every drop of STE, and you have to resuspend the bacterial pellet in alkaline solution 1 as described above. Okay, so this is in the rare case when you are using this particular strain. Particularly, you have to take care in the step 3, which I would recommend. Okay, so next is plasmid DNA is present before digestion with restriction enzyme, but it is converted into a smear during digestion, which is a very common problem. When you will digest the plasmid, you will see a smear on the gel, but before digestion it was a clear band on the gel. Okay, so what is the possible cause of the smear? So what is the possible cause? That your TE buffer has been contaminated, so you have to use the fresh TE buffer every time when you do the elution. Okay, so this DNA, which is most likely tainted or it has been degraded, you can say, with a bacterial DNAs, and this DNAs which is already present in the TE buffer uh, b- when it is contaminated, and when this contamination part, that is DNAs, when it comes in contact with Mg2 plus present in the restriction buffer, then there is a chance that uh, our plasmid DNA is like it shows a smear on the on the gel. Okay, so what you can do, you have to sterilize each batch of TE by autoclaving, and you have to make 1 ml aliquot of these TE buffer in sterile centrifuge tubes or microcentrifuge tubes, 1 ml microcentrifuge tubes, and you should use a fresh aliquot every day. Okay, you should open this tea stock bottle in the laminar airflow, and you can aliquot it in several Eppendorfs or the microcentrifuge tubes, and use a fresh tea buffer every time. Okay, so even if you find that bacterial DNA is copurifies with the plasmid DNA, then extract the DNA with phenol chloroform. Recover by standard ethanol precipitation and resuspend in fresh tea buffer. Okay, so if you find that even even after using fresh TE, you find that there is a DNA which is present, you can extract DNA with phenol chloroform. Okay, then recover it with standard ethanol precipitation and resuspend in fresh tea. So this is kind of troubleshooting for your plasmid DNA isolation. Okay.